So let's get started. First thing I want to establish is that a model, LLM, is actually stateless. What this means is that it doesn't have any memory. It doesn't know anything. It basically just guesses the next word, the next sentence that it needs to tell you, basically. And in order for us to have a conversation with it, it's actually something that requires a lot of back and forth with the model. So when you ask it a question, you think it answers you, and then you ask another question, and it answers you with the second answer that you've asked it. But you might have actually seen it that it reaches a certain limit, right? Especially in the beginning when you talked with ChatGPT or anything like that, it reached a limit and it couldn't kind of like continue from there. This is because when you ask it a question or the second question, it actually sends the entire history of your conversation to the model. And the model cannot take all of the different questions that you provided it, all of the history, all at once. So it's limited. And when it reaches that limit, it used to stop. So what we try to do in order to combat that, one other thing is that between sessions, originally, nothing kind of like transfers. There was no memory, there was nothing else. So one way that we started to try and combat this issue is by introducing a context window, basically deleting all of the previous messages that you had with the chatbot or in your conversation. But this is very lossy, and you might have experienced it where you were talking with your chat, and all of a sudden it kind of like forget what was the original intention of this call, or like really crucial details or instructions that you provided in the beginning. So in order to get around that, what we started seeing is that applications started implementing summarization. Summarization is basically just sending all of that history. If the model knows that it's currently reached a certain limit, we are sending the entire history to another model that basically summarizes everything, provides a short summary, and then this gets sent to the model to kind of like get the next answer. All of this is actually done by a tool or a term called harness. Harness is actually the application that surrounds the model, that calls the model, that basically manages that context window that we've just talked about. So after this was introduced, we've also seen memories being introduced. We've seen this in ChatGPT, but also in Claude and other tools that you might use, Copilot and whatnot. Basically, it started remembering certain things from your conversation. The model flags certain pieces of information you've provided it, saves it in a list in the backend, or asks the harness to save it in a list in the backend. And then this is brought up whenever it's necessary. So then we started seeing some awareness being introduced. And we say an awareness, what we mean is that you as the user are using currently a tool. You're seeing a page, you're seeing some information. You have a chat integrated in that screen. The chat already knows what you're looking at. It knows the data. So you don't need to provide it so many details about what it's currently doing. So the prompt could be much more short and much more concise. You don't need to reintroduce certain information to it. Then we've started providing it with tools. Those different tools that we provided required a multi-turn approach, which basically means that we are not asking questions and getting answers right away. We are actually calling the model multiple times with multiple turns. It's basically asking for the next tool that it needs with the information that it requires. It gets that data back, and then it improves its answer. So it does that multiple times and then until it gets to the answer that it wants to give you. So, for example, in this case, we're asking the model what's our exposure to current market rates. What we get is the model has a set of tools that it can call, and it selects from that. It goes through different data sources, asks a few questions, and kind of like builds up the knowledge that it needs in order to provide you with a concise and accurate answer about your portfolio. So you ask one question, it gets all of the data, and then introduce you with the underlying answer. Next, we've started seeing, or we've already seen that whenever you ask the same question twice, you don't really get the same answer. And when we started introducing tools, this became kind of crucial because those tools need to be called in a certain way. And also, if it creates something for you, an output of some sort, or let's say a document or an email, you want to have consistency. You want to know exactly what's going to happen when you call it. And in order to do that, skills were introduced. Skills is basically a set of instructions that is saved in the harness. And the model knows that those skills exist, and it loads them up when it needs to. You can also instruct it directly to use a certain skill, but this is what brings consistency and allows you to get the same format every time. So we've talked about various different parts, and basically this is what we call an agent at the moment. There's the model. This is the first piece that was introduced. We've seen in chatbots, but all of the other things are very instrumental to making this an actual agent. The harness is everything that is not the model. Oh, sorry. You've been seeing a different slide. Sorry about that. Okay. So let's see it in action. Okay. Okay. So what we're seeing here on screen is the Claude desktop app. Claude has an option that's called Co-work. It's the more agentic mode of Claude. And what it allows you to do is actually have that multi-turn approach. It can access your files and can do multiple different things. So today we've connected it to Hypercore and our systems, and we want to see what type of use cases we can use it for. So my first use case is to create a redemption letter for a borrower. So to start, let's ask Claude to go scour Hypercore and see what actual loans we have access to. So what it's doing now, it says working here, but it looked into his bag of tools and found the correct tool that it needs to use. And it started calling that tool and doing those multi-turns. So we can see each of those rows here are the turns that it takes. And in a second here, we'll see the final result. Okay. So it looked through my current account, and it found all of these different borrowers. So next, I'm gonna ask it to calculate the redemption amount for Meridian if they were to redeem in a month from now. So again, what it does is go through the tools, get the specific loan that we asked it to get the loan schedule itself. So it loads the amortization schedule. And from that, it's going to project what would be the redeemed amount. So we're going to let it run for a few seconds. In the meantime, are there any questions you would like to ask on this? Okay. Yeah, so it basically told us what the current rates are, what is the outstanding principal of that loan, and calculate that total estimated payoff, including the end of term fee. And it also notes here that we have a 3% payment charge on this loan, and it calculates that the amount needs to be charged as well. So for the next part, we want to actually start using those numbers that it got. We're going to assume those numbers are accurate without checking, although you should always check all of the calculations that the model does. So we're going to ask it to create a letter for us, a redemption letter. And we currently don't have any instructions, like no global instructions set up on this account. So it's gonna use whatever it thinks should be a letter, but we can actually ask it to use a certain format. Oh, in this case, he asked me a question. So what does 20% of discount on outstanding principal apply to? Which is really good question, because we don't want to actually discount the principal, right? So we only want, off all but principal. Thank you. But principal. And let's do Crestview. That's the lender. Okay. So it not always asks me questions, right? Each time it's a bit different. And this is due to the nature of models. They're statistical tools, and they guess the next thing that they're going to do. And this is why it sometimes can ask, it sometimes would not ask. But if we wanted to ask questions, we need to instruct it to do it. So
you define the guardrails at the back end?
At the moment, we didn't define anything. This is Claude as is. It's just deciding what it needs to do. And we'll show in a minute how we can make this a bit more consistent, as we talked about. So what it's doing now, it's actually writing a script to create a document. It doesn't really have access to my Word application. So it's building a script, and it's going to run it in a minute to build that document. And we will be able to see what it is, what it produced. Okay, so it's running it now. Yeah, here it is. So this is the letter that it created for us. And we can see that it discounted only the amounts other than the outstanding principal. And it also included a bunch of different information that it thought should be in a redemption letter. So again, I'm going to use this as is and then send it to my manager for approval. So Daniel, expect a message in a minute. I'm using the Slack integration in this case because we use Slack, but you can actually use whatever other tools you might have. And what we wanted to note here is that we think this, as an example, is really changing how we integrate our systems in our organization. It allows us to take the various tools that we have now, connect them without having to have an engineering team that building out those integrations. Because this is, again, an example of me prompting it, but this can be automated and can be extended as well. So let's send that to Daniel. And then lastly, we want this to be sent as an email to the board for review, assuming Daniel approved, of course. So we'll ask you to draft that email for me. I've asked you to draft it as a, not just by text, but provide me the actual email file, because it's going to allow us to have the actual attachment as well in it, so I don't have to kind of like drag in the file that it created as well. So again, trying to kind of like minimize the actions that I'm doing. And we would be able to see, sorry, if I scroll to the right here, that this is the email that it created. For some reason, it messed up my name. It called me David Yaffe, which is not my name. But yeah, like that's the email that it just created. It also holds the letter that it created with all the information that we've already seen. So that's great and all. This was like a back and forth that I just did with Claude to kind of like get to the process. But this is something that I do, I don't know, like once a month, and I don't want to kind of like every time go through the same process and do this back and forth. So one way we can do it is we can actually, you know, have a prompt, right? Like create all of the instructions, save it aside in the file or whatnot, and let that or repaste it every time to kind of like do what we want. But another way, and we've discussed this in our presentation, is we can just tell Claude to create a skill out of it. So Claude, or Anthropic, I should say, has created a skill that is able to create a skill. So this is very meta here. But what we are seeing is that when I asked the agent to create a skill, it loaded up that information, how to create a skill, and now it goes through that process to create what we need. So it asked me some questions. Should a skill always include a Slack approval? Let's do full flow always. And run the skill creator eval loop, or just build the package. Let's do just build a package for now. Okay. So again, it's going through the steps. We will see in a minute. What it's doing basically is creating a file with instructions, and it's also attaching a few more bits of information to it. Typically what it needs is, as we've seen, are scripts to create those different files that we've asked it to create. But when we've asked it in this conversation, it created that from scratch. With the skill, it doesn't need to recreate it. It's already saved there, so it doesn't need to kind of like redo the whole thing. So while we wait for that to complete, I want to show you one more thing that we think is really good example of using Claude for day-to-day work. So we at Hypercore have an instance of Metabase that's built on top of Hypercore. It's a BI tool that we use day-to-day to build, you know, reports for clients, and they get that embedded into the app. What we've configured here is a Metabase connector for Claude that is able to connect to that BI tool and create reporting in real time. So we're going to ask it to go in and check what is the IRR across all of my active loans. And as we wait for that, let's see if it finished. So yeah, it created this skill file. which I've already explained. This is just the instruction file, same as if we were to save that prompt to the side. And then, one sec. We are going back to this. We're going to allow it. Okay. Yeah, so it, just to show you what it did, again, gone back to his bag of tools, found the execute query tool that it needs, created a report, and just ran it. So that way it provided me with this information. And yeah, that's nice and all. This is information that's already calculated in the system. But what if I want something that is, projection, something that is not currently in the system? So I'm going to ask it to visualize our current nominal interest charges each month projected over the next 6 months. So it would do a similar flow. It would run the query now, or build the query and then run it. And then what it would do is it would actually try and visualize that in chat. So jumping back to the scale, instead of waiting. So yeah, this is the skill that it built. Again, just like a folder with that file, skillmd, and the script that it needs, and then another markdown where it provided instructions for itself how to use the scripts. So just to test that and show how this can save us some time with the back and forth, we're going to ask it to run the early redemption workflow for Breakwater, which was one of the clients that we've seen here. Just a different loan. This one is still working. Yeah, so each one of those conversations on its own is an agent that's currently running. And one thing that you can do with Claude is actually schedule these things. So you can do schedule tasks. Currently with this, it's meant for personal use, so it would run on your computer. So not ideal, but if there are certain things you would like to do, this is also possible. What does Hypercore want to redeem? When? Let's do next week. No discount. Daniel. It's working hard in this one. Any questions up to this point while we wait? Yeah.
So I'm just wondering, to this, like, if you did it for one of your clients, it would primarily be accessing all these workflows is a call an agent, but not how, I mean, I guess, how are the clients using just Claude or other agents?
So it doesn't have to be Claude. It really, like most tools, like these type of agent apps now supports a thing called MCP, which is a protocol that allows you to define how those tools are working. So it's very interchangeable. You can actually take the Hypercore MCP, which is the connector, put it into your Copilot or for your ChatGPT agents, or into Claude as we've shown here. And yeah, that's kind of like the integration that you need. And when it has access to that, it starts working. We prefer Claude on our own, but it's just an example. Yeah.
But in those examples, the Hypercore platform is just the data layer, and the quality of the results is highly dependent on Claude. It's not dependent on what you have in Hypercore.
So depends. Hypercore does. Yeah. Oh yeah. So, yeah. So I'll repeat for the microphone. They were asking whether or not we can reuse Hypercore MCP in other agents, and then the follow-on question was whether or not Hypercore is currently just the data layer and we rely on Claude smarts, you might say, to kind of like get the results that we need. And some of that is true, right? Like if we wanted to project things, if we want to calculate things, it is dependent on the app that you use, the harness, and the model that it uses. So you can get varying results depending on what you choose in that manner. So that's why, again, we prefer Claude exactly for that reason. Claude is really accurate in doing such long-running agent work. But again, like this market always evolves. Every month you can see a new thing. Yeah.
Can Hypercore? Can everyone hear me? Can Hypercore integrate a second LLM to fact check? I mean, obviously, you can't get a loan wrong. You need 100% accuracy.
Of course.
And I know some people, will pit LLMs against each other to test each other. What's your functionality there?
Yeah. So again, we're not showcasing Hypercore in this particular demo. Just want to clarify. The question was whether or not we need to or can we integrate multiple agents to fact check each other or to check each other's work. So to answer this, basically, you mentioned LLMs, different LLMs. The models themselves can be different, but what is actually more important is that have different instructions, right? One agent have the instruction to create something, and one LLM has the instruction to check the other LLM's work with possibly supporting information, possibly more instructions about like what it needs to do in order to prove out that this model has done its job correctly. So the answer is yes, like you can do it with just this tool by basically taking whatever it created and in another chat just put it in there, asking it to verify. Or there are definitely tools, and we will show Hypercore in a moment and what we have in Hypercore itself about that. And yeah, like that you can just like from the beginning let it know that it needs to create and then spawn another agent that will fact check that. Yeah.
Could you tell me a little bit about the tokenization usage tracking, especially when creating these skills, how efficient they are for repeatable extractions in the future, and make it one more way perhaps to save some costs there per user usage for widespread implementation?
Mm-hmm. So just to clarify the question for myself, are you asking about the how, like, if skills themselves are more efficient than like just prompting, or is it like another question?
Mainly just tracking token usage. So one skill might achieve the exact same output but require triple the tokens, and they're to be more costly in the future for repeated usage. So I was just curious, and maybe this will come later in the demo within Hypercore specifically, but is there a way to kind of track that in real time to make sure you're
Yeah. So the question was whether or not we are, or is there a way to understand what is the cost per token on each of those requests, and whether or not we can see if skills improve that, reduce costs, or not. So like it's a two-pronged question here. For this particular tool, you can't really look at just it and see it. You can see it in the settings, but it's not a per request report. However, when you use APIs like Claude's API and whatnot, you are able to see per request the exact usage. So it is something that is possible, and some tools allow for that. It's back, yeah. In terms of the efficiency of the skill itself, what is nice about skills is that they do not load into the context right away, and what dictates how much tokens you're gonna spend is very much tied to like the context that you're providing to the model. So because skills are lazily loaded, which means that the model decides whether or not it needs that, it can go in and load it if needed. So you can have multiple skills, like in the tens that we've tested up to this point, but like officially they mentioned more than that. And it would only load up the information that it needs. So like we've seen that script, we've seen the instructions, but it can also load up parts of that, right? Like if it had more examples or just part that is specific to how it can use a certain thing, I can search from that and only load that into the context. And this what should reduce dramatically the tokens usage. But again, it varies from platform to platform. I'm not here specifically defending or suggesting for Claude, but in general, it is possible. So just to kind of like wrap up this, and we'll have time for questions later as well if you have some follow-ups. What we're seeing here is that Claude was able to not only pull the data, but also provide a visualization of what our interest looks like for the next 6 months in nominal terms. And do we have time, Shai? Yeah. Okay. And what I wanted to do next is to do something that we've heard a few times already, especially from public funds, where you need to do a sensitivity check on your interest payments in terms of rate changes. So what I've asked it is to tell me what would happen if the market rates would drop 1, 2, or 3%, and provide this analysis to us. So it's going to use the same data that it had before, ask some more questions, and then create a similar visualizations to what we've already seen. And yeah, like lastly, with the scale that we've shown before, we can see that it was able to use the scale, use those instructions that we've provided it, the questions that it asked, create the redeeming amount, and provide me all of the different outputs all at once. So we have the document, in this case, again, this one is for Breakwater. And it also provided the email and the message to Daniel, which I will send now. And yeah. Second. Bow. That's the email. Again, just butcher my name. Okay. Let's click on the wrong thing. Let's see the visualization here. So yeah, it was able to do that, providing with a projection. Yeah, any questions?
You're doing that, you're uploading, borrower documents, loan documents, payment schedules. How exposed is that information? Put that on Claude, is it
So
any confidential?
So in order to talk about that, you need to like understand what's going on. But when you call Hypercore, the Hypercore data is retrieved. It's not going through Claude on its own. It is sent to Claude as part of the context. That data, as we mentioned, it's a stateless machine, so it doesn't automatically saves it. It can save it, right? Like they can have logs or technical facility to kind of like have observability of how it was used, but it's not necessarily being sent as on its own, right? So you do need to make sure in terms of like security that the tool that you use have SOC 1, SOC 2, all of the different certification in order that, and you are able to trust that with the information of your clients. It is something that we do as well. Hypercore is SOC 1, SOC 2 certified as well. So all of the vendors that we use, we make sure that are at the same level or higher. So that's another reason why we use specifically Claude, because they have really good SOC report on its own. Like in every report, you would see if there's any exemptions or if there are any problems there, and they have a really good one. So So yeah, it is a risk like any other cloud software, but it's not specifically more inclined to expose any client information than any other cloud infrastructure. Other questions? Okay, so let's wrap up. So again, what we've seen here is just a demonstration of a general harness. We used Claude here to demonstrate, but what we've just shown is a very personal experience, right? So we're going to talk about the caveats of this tool and how it can be resolved in the next demonstration. And now we're going to a short break. Want to say something?
20 minutes break.
Okay. Thank you, everyone.